Hello everyone, my name is Max Metzger. I'm a reporter for SC Media UK. Welcome to today's webcast, How to Do Flow-Based Security Monitoring at 100G, sponsored by Napatech. The ability to detect threats at any speed is a challenge, but with networks now operating at 40G and 100G, these challenges become even more complex. For those that want to fix this problem, there isn't much out there. The real lack of commercial offerings capable of meeting industry demands mean that many might be prepared to do what the market won't and build their own. But how do you get to square one? How do you go about even building a solution that can provide complete traffic visibility even at speeds of 100G? Well, I'm very happy to say we've got two people here who will not only be able to answer some of those questions, but Ntop founder Luca Deri will be explaining how they helped a global hyperscale internet company do just that. By developing a one-to-one Netflow solution with zero packet loss, they successfully enabled complete and efficient traffic visibility even at 100G. Luca is not just the founder of Ntop, but which specializes in developing open source tools to monitor high-performance network traffic, but holds a great variety of other positions too. He's a research fellow with the Institute of Informatics and Telematics, collaborating in the R&D activities of Registro.it, and cooperating with the Computer Science Department of the University of Pisa, where he teaches network management. Previously, Deri worked at University College of London, IBM Research, and at the University of Bern, Switzerland, where he received his PhD in 1997. Daniel Joseph Barry, who will be joining Luca, is VP of Positioning and Chief Evangelist at Napatech. Dan brings over 20 years' experience in the IT and telecom industry to the table, in roles ranging from research, development, product management, sales to marketing. Dan holds an MBA and BSc degree in electronic engineering from Trinity College Dublin and joined Ericsson in 1995 from a position in the R&D department of Jutland Telecom, now TDC. He went on to a variety of positions in product development, business development, and product management at Ericsson before becoming Director of Sales and Business Development at optical component vendor NKT Integration, now Acelink, in 2001. He then joined TPAC, now Intel, as Marketing Director before landing at Napatech, the world leader in data delivery solutions for network management and security applications. Napatech's products use patented technology to capture and process data at high speed and high volume, with guaranteed performance, enabling real-time visibility. We will have questions after, but for now, let me introduce our speakers, Luca Deri and Daniel Joseph Barry, presenting today's webinar, How to Do Flow-Based Security Monitoring at 100G, sponsored by Napatech.
Thanks very much. So this is Daniel Joseph Barry here, and I'm just going to lead you in to this very exciting presentation today. We're going to be talking about how to do flow-based security monitoring at 100 gig. And of course, we're talking about 100 gig today because that's the most challenging aspect of what we're trying to do. But some of the solutions that we're talking about today are equally applicable at other rates. This is just the most challenging that we're talking about. And we'll be having a specific focus on security. And we'll be talking about a case where we're working with a hyperscale internet company. And we're very honored today to have Luca Deri from Ntop join us. He worked together with us in providing that solution. And I would safely say Luca is probably regarded as one of the experts in packet capture, if not the guru on packet capture and flow-based monitoring across the globe. So I think we're very honored to have him here today so he can go through it. What I'm going to do with start here is actually just kick off around some of the challenges in security. That might set the scene a little bit and give people an appreciation of what we're trying to achieve here with the solution that we've put together. So just to kind of set the scene here, I think some people might be aware of this, but others may not, that there's a fact right now that anyone who's working with networks, internet communication networks in general, would certainly feel that their networks are under siege at the moment from a security point of view. We're seeing security threats increase in size and scope and in frequency. And I've just taken a few statistics here from Symantec's Internet Security Threat Report from April of last year, which gives people an idea of what we're up against. So in that report, they showed that there was 431 million new malware variants discovered in 2015, the year previous. Now, that was a 36% increase compared to 2014. Now, there's lots of different types of malware variants, and some of them are already known. But if they're unknown, they're often considered new zero-day vulnerabilities. So these are threats that have never been seen before. And during 2015, a new zero-day vulnerability was discovered on almost a weekly basis. So that was a 125% increase compared to 2014. So that gives you an idea of the scale and the number of different threats that we're facing. The interesting thing is it's not something that's just confined to big companies. One of the main methods to hack into a company is using spear phishing. I think many people have received one of these emails or maybe a fake web link where you press on it and then suddenly you've downloaded some malware. So spear phishing is something that you see is being used to deliver some of this malware. But what we saw in 2015 was it started to target employees, and it increased 55% in 2015. But what's really interesting is that 43% of those attacks were against small businesses. So this is no longer something that big nation states or large corporations have to worry about. It's actually everybody. Even small companies, down to a few dozen people, have been attacked in this way. So it is certainly something that we have to take extremely seriously. And the cybersecurity community is really working hard to try and find solutions for this. Now, there's a significant cost associated with these breaches also. And one of the things that clearly comes through is that time is a critical factor. So again, I have some statistics here from the cost of data breach study that was performed by Ponemon Institute in June 2016. So we can get an idea of how serious is this. What they determined, based on the breaches that happened during 2015, was that the average cost of a data breach was about $4 million, or $158 per lost or stolen record. Think of that as a Visa card, for example. And that was a 29% increase on a couple of years previously. So definitely that cost is increasing. The average time to identify a malicious attack is actually a mind-boggling 229 days. So even though we have made large investments in lots of different security solutions like firewalls and what have you, there are attacks that are going unnoticed for almost up to half a year. Now, when they are discovered, the time to actually contain that attack is about 82 days, right? So trying to figure out what's going on and actually do something about it. So these are very long time periods here. And there's a cost obviously associated with that, as we've seen. But one of the things that's also been noted is that if you can detect these things faster and act faster, then actually you can save a lot of money. As a matter of fact, if you can identify it within 100 days and identify and contain that threat within 30 days, you can lower your cost by about 26%. So time is definitely of the essence. So there's a couple of things here to note. One is that the security perimeter defenses that we have aren't catching everything that they need to catch. So there definitely the need to look at what other solutions might be available or what other approaches are needed to be able to make sure that we can detect these breaches when they occur and that we can contain them quickly. Now, Gartner have looked at this, and Gartner is probably one of the leading analysts in this area. Not the only one, of course. There are others like Forrester who are also thinking along similar lines, but I've just chosen Gartner here because they've defined a concept called adaptive security architecture for protection against advanced attacks. And in that they have this drawing, which I'm showing here, which gives you an idea of what they're actually recommending to their customers. And what they're saying is that really the solution is to look at continuous monitoring and analytics. In other words, keep an eye on what's happening in your network and know what's happening at all times so that you can react quickly. Now, as part of that adaptive security architecture, they do recognize the need to have those preventative mechanisms like firewalls and intrusion prevention systems, which are very important at stopping the known attacks. And then we saw there's 431 million different malware variants out there. So definitely there's a lot that can be stopped just at the door. But also there is a need to have specific solutions for detecting these breaches that may have got through those defenses. So you need prevention and detection working in tandem. And that detection, of course, will be very dependent on those continuous monitoring and analytics that you perform, so you know what's going on in your network and can actually identify malicious behavior. Once you can do that, then you can start responding and responding really quickly to that. You can do deeper forensic analysis of it, determine what exactly happened, what was the cause, what was the pathology of that attack. And once you start learning more, you can start building that back in to your systems. You may even be lucky enough to predict what's going to happen next based on what you've seen in the past. So you can certainly see some indicators that something's on the way. And that really gets built back into your prevention and detection solution so it can be even better next time. So that's the basic idea of this adaptive security framework, and it's what's guiding a lot of the main thinkers and vendors and other people working in this space today. So in the case study that we were working on, we worked with a hyperscale internet company who were struggling to do continuous security forensics monitoring at 100 gig, which was their speed. And they had some difficulty trying to find a commercial solution that could operate at these speeds and do things to their satisfaction. So they wanted to implement this a detection solution that would be able to be part of that adaptive security framework that they needed. So but the challenge, of course, when you operate at 100 gig is that's a lot of information that you have to look at in real time. So they need to have some sort of mechanism to reduce the amount of traffic that needs to be analyzed in real time, and find some way to lighten the burden of doing that. But at the same time, they need to have the ability to zoom in on particular IP flows and capture selected packets to disk. So they need some mechanism so they could see enough detail to make good determination, but not so much that it would overwhelm the processing resources that they have, but at the same time be able to select which flows they want to really dig deep on and actually capture those to disk so they could do some deeper analysis on those ones. The solution that we came up with together with Ntop was actually to ensure that we were able to do 100% packet capture in real time, and that could be written to disks. And that had to be done at 100 gig, so we had to make sure that we were able to capture all the data at 100 gigabits per second, no matter the load on the network, which is a technical challenge in itself, but one that we've overcome. And one of the secret sauces that we put into the solution was this one-to-one Netflow generation, which I'll talk about in a minute, which is actually one of the things that makes this solution tick. What that enabled then was real-time analysis using either open source or commercial applications. So it's a framework, if you like, or a platform that would allow the customer then to apply different types of analysis, security analysis, forensic analysis, using any type of solution that they wanted to. And definitely both open source and commercial applications were used in order to do the analysis that was required. So just to provide a little bit of info on what one-to-one Netflow is, because I think that is something that may be new to a lot of people on the call. So at one extreme, the ideal is to provide full packet capture. So when you do full packet capture, basically what you're doing is you're looking at all the traffic that's going on in the network, and you're capturing every single bit of detail of that traffic with nanosecond accuracy. And that's the most complete record of network activity that you can get. It's so detailed that you can actually replay what you've recorded almost exactly as it happened, which is obviously fantastic when you're trying to do any sort of forensic analysis or security analysis. But it does require the ability to capture and process traffic in very, very large volumes and at high speeds, which does take a lot of CPU cores, a lot of resources there, and have applications that can keep up. And that's a challenge, obviously, at 40 gig and 100 gig. So any way that you can try and lighten that load is very welcome. So what a lot of people do is use a sampled Netflow approach. So instead of looking at the packets, they create a record, a Netflow record, which is based on a sample of the network traffic. So that gives them an idea of what's happening. It gives them a trend, if you like. But it's not very complete history. Obviously, you don't have all the details, and you can't replay things exactly as they happened. So a lot of the details are missing. Now, it can be great for performance monitoring, if you want to just get a general idea of how things are doing in your network, a Netflow record would be just fine, perhaps. But if you want to really do deep security analysis and find out what exactly happened, especially if it's a new threat, a new zero-day vulnerability, you really need to dig deep and try to figure out what exactly happened there and try to piece together the picture again. So it's not always sufficient for network security purposes. The compromise here is to do something called one-to-one Netflow. So what that does is, instead of providing all the packet and all the details in the packet for analysis, you create a Netflow record per packet. So the reason why this actually reduces the amount to be analyzed is that at this point you're just looking at the sort of summary information of the packet, but not all of the bits and bytes that go into it. So it will be a smaller amount of information that you need to analyze. But it does provide a very complete idea of what's going on, because you can capture in there what the timestamp was, what all the details were, the header information, all of these different things which are useful for analysis. You just may not have the exact payload in there. But it actually does provide a quite complete picture of what's going on in the network, and does allow you to pinpoint where malicious traffic might be entering in. So it is actually quite ideal for network security, whereas I need to reduce the processing burden. So it's kind of, if you look at it as we've drawn it here, a happy medium between the two extremes of full packet capture, which is quite intensive and hard, and then sample Netflow, which is easier but may not be as detailed as you need. So having presented that and provided that context, I'd just like to invite Luca now to actually take us through the flow-based network monitoring solution that we made for this company, and provide a bit more details about the Ntop solution that's behind this, and how that actually works, and what the benefits of that are. So Luca, if you could take it from here.
Yeah. Good morning. My name is Luca Derry, and I am the founder of Ntop. We are doing network monitoring since more than 15 years. And today I'm going to talk about 100 gigabit flow-based monitoring. That per se is a very challenging environment. Now let's talk about 100G. Why is 100G so important? People don't have to assume that 100G will happen in a few years, because 100G is a reality today. In fact, if you look at servers, you will see that the transition from 10 towards 25 and 50 gigabit is happening. You will see that on the motherboards, the speed is increased quite dramatically, and that computing power is now enough for processing data at higher speed. The need of 100G is because there is a lot of data on the cloud. Companies are exchanging a lot of traffic, and the transition to 100 gigabit is also becoming because of the switches and the routers are now able to keep up with 100 gigabit at a reasonable cost. Because years ago it was a bit expensive, but now the prices are decreasing. That makes possible for the infrastructure to move and migrate towards 100 gigabit. This means that if we want to analyze 100 gigabit backbone, we need to be prepared to have the possibility of capturing traffic on a server, because it's on the server that network monitoring is happening. So this is the reason why we need efficient 100 gigabit network adapters onto the server and not just on the infrastructure. For years, many companies have focused on the basic problem of capturing and filtering traffic that was very challenging, because you know that it is very complicated to do complex activities such as security, and at the same time to have time to capture all the packets, because packet drop is an issue, because it prevents network monitoring to happen properly. And also filtering, because when you have a backbone, sometimes you need to focus on specific host traffic, so therefore you need the hardware to do this activity instead of doing it in the CPU, because the CPU must remain free for monitoring tasks. Because of that, the challenge was to capture traffic, and those applications that were able to do that in conjunction with FPGA-based adapter were a bit simple because they didn't have very advanced capabilities. They analyzed traffic simply at the packet level without any further monitoring processing tasks, such as computing latency or understanding whether users were downloading proper content or not, or the response from the server was a positive response or was an error. But now we have another challenge that while the speed is increasing and while this is becoming more complicated, we have to make sure that the solution is compact in terms of rack space, because modern cloud centers contain several thousand servers. So therefore, we must make sure that our solutions are efficient, but at the same time are small. So therefore, we need to collapse many facilities that were available on different boxes previously into the same box. This means that we have to combine, for instance, network monitoring and network security onto the same box. And this is an extra challenge that we have to take into account. Now, because we moved to 100 gigabit, the problem of packet capture, like I said before, has been solved efficiently in FPGA-based adapters such as the Napatech. But this is just one part of the problem. The second part of the problem is that we need to integrate this with other components. And a typical component can be a security application, or today we are talking about network monitoring. But because the cost of capturing the packet is a bit expensive in terms of memory bandwidth, CPU utilization, and so on, because the FPGA-based adapter is accelerating that process, but at the same time, the application has to keep up with 100 million packets per second plus. So therefore, we need to be efficient. We need to reduce those tasks that are not necessary. This means that we have to capture the packet once, and we need to distribute this packet towards several applications so that we don't duplicate the effort like we do at a lower speed where the CPU utilization is not an issue. So therefore, another problem we tried to solve was to distribute the traffic to multiple applications. So this means that we capture the packet once, we make a decision based on the packet on the flow, and in case a certain decision has been made, we need to forward this packet to another application. Let's make an example. So suppose we find a security issue with a certain flow, and we want to analyze this a bit more in detail that a simple network monitoring application cannot do. So therefore, we need to forward this packet towards another application running onto the same box. This is a typical problem that we need to solve, and also some time, because the traffic rate is so high, we need also to distribute the traffic towards multiple applications so that they share a part of the workload, and each application is doing a certain task. So this is called traffic balancing. And another things that we have implemented is pipelining, because like I said, one application can capture the traffic, another application can do security analysis, another application can do network monitoring. So therefore, the same packet has to be delivered in sequence from one application to another. All these features are a bit challenging in terms of pressure on the CPU subsystem and on the memory subsystem. So therefore, we need to optimize the application quite a bit to make sure that we don't exhaust the available computing power. 100 gigabit was an interesting problem for us, and it was also a bit challenging for an hyperscale internet company that approached us a couple of years ago, and they wanted to monitor every single bit of their links because they wanted to create a log of the traffic so that in case of a security breach, they wanted to understand the origin of the problem and to understand also how the problem was created. Unfortunately, this is a bit challenging because we have to combine this with the disk space and also with rack space. So the solution was supposed to be very small in size and also in terms of rack units. So they approached us because they were unable to find such a solution on the market, and they also understood the benefit of FPGA-based adapter, also the benefit of our software. But we needed to combine these two into one box that was also able to provide some security features. And this was the real challenge, to integrate all these three components into one box at very high speed. And also, you don't have to forget that at 100 gigabit, you will end up producing a lot of monitoring data. And this traffic has to be sent to a system that is capable enough to handle the workload. So typically, this is delivered by a big data system. So therefore, the complete solution had to be integrated with streaming to a big data server so that we can send in real time monitoring traffic towards this system that can make decisions and that can change the configuration of our solutions so that security application can be enabled selectively based on the traffic conditions. This was the reason why we have developed from scratch a new application called nProbe Cento. Cento in Latin means 100. This is the idea, to create an application that is fast enough to handle 100 gigabit network links, to analyze Netflow, no sampling, every single packet, and then also able to provide modern monitoring metrics. Because, like I said before, packet and bytes are no longer enough. We need to do more. We need to provide users some metrics that allow them to understand whether the network speed, the network latency, the service time were good, and that in this case, what type of experience users are doing from using the services. This required us to create from scratch a new application because it wasn't possible at that speed to reuse existing code, existing lessons learned, because everything was supposed to be very efficient and also designed to exploit all the features available on Napatech adapters. The architecture of Cento is the following. We have the ability of merging traffic from various network adapters and to deliver them to multiple threads. This happens in the Napatech cards. Cento, therefore, internally is split in several threads, processing threads. Each thread is processing a part of the traffic and integrates inside the engine a deep packet inspection component that I will be describing later. So this means that we are not able just to account the traffic, but also to characterize traffic and to identify the application protocol exactly using the DPI toolkit. Based on this computation, we generate flow records that are sent to a big data system in a compressed format, and at the same time, we have the ability of delivering selected packets towards security applications. In this case, we are focusing mostly on two IDS applications. One is nProbe, the other is Suricata, that are leaders in this market. And those applications are receiving selected traffic. This because there is not enough CPU power, also not enough interest in analyzing all the traffic. But we wanted to focus only on selected flows that were identified as special by the big data system. And in case there is something important happening, so suppose a security violation or a sudden traffic peak, it is also possible through a feedback channel to reconfigure Cento on the fly and selectively dump packets to disk that are satisfying those criteria. So this is a very dynamic system. It is not an application that once configured stays with that configuration for the rest of the life. But the configuration is updated dynamically by external application based on traffic conditions. The design principle of Cento is that we wanted to create an application that is open to extensions, that it is not self-contained, but that can deliver monitoring data to big data systems. So therefore, we had to integrate, for instance, exports not just in Netflow or IPFix format, that is the de facto standard in this industry, but we also had to export data in JSON format and Kafka, that are two types of technology that are very well used in in this area, in big data system. The leveraging on the Napatech card has allowed us to simply forget the problem of merging network interfaces together and distributing traffic, because this happens into the Napatech card, whereas the application is focusing on reading packets and making sure that this traffic is properly analyzed. Like I've said before, the feedback channel is an important component of the solution, and this is implemented through a REST interface so that a security application can connect to Cento and change the configuration based on the traffic conditions. The problem of DPI is definitely that it's a technology that is necessary today, but it is a bit expensive in terms of computing power. For years, we have maintained a DPI toolkit named NDPI. This toolkit is open source. It contains more than 200 protocols. But the thing is that this toolkit is not possible to be deployed onto a 100 gigabit application, because the time it takes to analyze and detect a flow was too high for that speed. So therefore, we had to reduce the number of protocols and also to increase the efficiency of the toolkit by focusing on those protocols that this hyperscale internet company was using. But at the same time, we wanted to preserve most of the features that the toolkit offers, so that users don't see any noticeable difference in terms of features, but they will not see any performance degradation because of the toolkit. So this has allowed us to focus on internet protocols to generate DPI information very precise at application level, and at the same time to have a speed degradation that is almost unnoticeable because of the efficiency of the toolkit and because of the way the network adapter is putting packets into the CPU cache, so that all those packets are immediately available for processing. This graph shows the scalability. This is a simple example that we wanted to extract from a specific environment. As you can see, the yellow line is the theoretical scalability based on the number of cores. And on the green line, you will see the scalability of our solution. And on the blue line, you will see the scalability of our solution on a very low-end box that is suitable for doing 40 gigabit monitoring. As you can see, the efficiency of the network adapter and the efficiency of Cento has allowed us to handle 100 gigabit of traffic with about 10 cores. So this graph shows that theoretically, with line rate traffic that we don't observe on our network, because real-life traffic is less than half of this traffic depicted on the picture. It is possible with a E5 box that is pretty common these days to monitor a 100 gigabit link. So this means that with two CPUs, you can monitor 100 gigabit full duplex or two links, or that with a low-end E3 box with an Napatech 40 gigabit card, you can monitor a 40 gigabit link using a very cheap and compact solution. This shows that the original project goals were achieved, and that we can do really security and network monitoring onto one box, using a reasonably cheap server. This is an example of a log. As you can see, with 10 links, we can handle about 10 gigabit of traffic per core. So therefore, with about 10 cores, we can handle 100 gigabit. Like I said, on a real network, we don't expect to see over 130 million packets per second, but this is the demonstration that even in the worst case, the application is performing as expected. So just to wrap up, the main remark I would like to make is that it is possible today to do 100 gigabit monitoring using commodity hardware without using specialized hardware. So a standard server can do the job when combined with an FPGA-based adapter and efficient software. The ability of exploiting modern hardware is very important, because it allows us to distribute the traffic across all the available CPU cores. And also, this means that it is possible really to scale up. Like I've said, with 2 CPUs, you can go towards 200 gigabit onto a single dual CPU box. We have also demonstrated that what many people claim, so that 100 gigabit is challenging, packet and bytes are the best we can make. It is not true, because we can make very detailed Netflow generation. We can analyze the application protocol with a deep packet inspection toolkit. We can monitor quality of experience metrics such as network latency, application latency, and response time, all into one single box, one unit, able to deliver to customers what they expect and to send this monitoring the information towards a big data system. Hello?
Thank you very much, Luca, for that riveting presentation, and Dan, for yours as well. Now we'll go on to some questions. And I guess the first thing I wanted to ask was, why is there this kind of gaping hole in the market for this kind of solution? Why aren't there more industry-level solutions where you can gain complete visibility, and what kind of demand there is out there for this kind of solution? I was hoping both of you could answer that.
Well, Luca, if you want to take the first part there, and why is there a demand for this kind of solution?
Okay. Yes. The demand is high because, like I've said before, people are moving towards 100 gigabit these days. And the ability of collapsing several links onto a single 100 gigabit link is very important, because it allows people to save money, to save the rack space, to have one single place from which we need to, capture packets. So the demand is increasing. At the moment, we see that the transition towards 25 and 50 is not yet strong, but, it's happening. This at the server level, but for traffic analysis, we need to do 100G, because this is the speed of the link, is not the speed of the Ethernet interface on the server. And 100 gigabit is also becoming more and more important, because many servers are now able to deliver this speed without very expensive hardware. So if today you have to make an investment and you have to update your data center and to add new components, you will definitely move to 100G instead of investing money on a 40G. That is a technology that will not last that long compared to 100 gigabit. So the demand is increasing. We have seen that many people are interested in having a 100 gigabit solution. Maybe not all of them need the solution today, but they want to make sure that the investment that they make will be preserved in 1 or 2 years when they will make the move to 100G. They don't want to reconsider, the components and to buy new elements, but they simply want to update the network adapter, the network infrastructure. So this is why today, even those that don't need 100G at the moment are interested in 100 gigabit solutions, because they want to preserve their investment.
Yeah, if I can just add to what Luca said, because obviously Luca took the aspect of 100 gig and what's driving that. But if we look at it from the security side, obviously there's a lot driving that as well, because what the solution enables you to do is to be able to monitor everything that's going on in the network, and using the big data analysis determine when you want to go deep and try and investigate things further. And to do that in very quickly. So tying that back to what I was talking about earlier, it actually reduces the time it takes to determine what's going on and react to that, which we've seen is quite important. So even though this is a solution that's 100 gig, that kind of capability is applicable at any network speed. And I think that, as Luca alluded to as well, the efficiency that's built in to the solution of being compact, not using any more resources than you need to, is obviously becoming more and more important. This particular customer here is a hyperscale internet company, and these kind of companies have been a bellwether for the industry in general. They're the first to see these challenges, they're the first to deal with these kind of volumes, and they're normally the most innovative as well in trying to solve them because, well, there probably isn't a solution out there. They're the tip of the spear in a sense. So what we see these guys challenging now is what most people will be forced to address in a few years' time. Not even a few years, actually, maybe even just a couple of years. These developments are moving very quickly. So I think that many people should take note of what's going on here. Because I think a lot of people will be facing these challenges very quickly. But the good news is this is, as Luca also referred to, this is actually a solution that you could start off with even at lower speeds and get benefits from it already today and know that you can actually quite easily upgrade from 25, 50, 40, 200 gig when the time comes because the actual accelerators, the cards that we use are all based on the same common software, on API. So you can actually mix and match those cards as you will. So once you've installed it once, actually upgrading to a higher speed is actually quite trivial. It's just a case of exchanging the cards. So I think we've got a very good, scalable and future-proof solution here.
Again, for both of you, are there any particular sectors or industries that you feel would most benefit from this kind of solution, or do you intend this to be kind of a panacea, a ubiquitous solution?
I believe that internet companies and cloud centers are definitely the first targets for this solution because they are moving a lot of traffic and because they are concentrating those services into one data center that is very dense. So it means that there is a justification for having 100 gigabit links full of traffic, because sometimes we have observed that people are moving to 100 gigabit but they don't have traffic. Whereas here, we see that, with cloud providers and hyperscale companies, the traffic, is very strong. We see high-speed links, a lot of traffic, many computers, many users. So this, from my point of view, is a place where, we see a lot of interest. And also those people, because they are on the internet, they are not inside a private area network, they have security issues. So they have to focus not just on network monitoring, but also on security. Therefore, it is important, the combination of monitoring with security applications, because they can have both of them, onto a single solution.
And I guess, what kind of cost can a business looking to implement this kind of solution expect when thinking about going into this?
Like I said, the cost of the hardware is pretty standard, so we don't need anything special here. Of course, 100 gigabit cards are more expensive than 10 gigabit, but there is not a huge gap. So the total solution, I think, is pretty reasonable in terms of cost and also in terms of maintenance, because everything is self-contained. You don't have to go to various vendors and buy components that are not integrated, but everything, is very well integrated.
So, next question. If one-to-one Netflow is sufficient for security, then why do we need to capture packets to disk?
Packet to disk don't need to be captured all the time. But if you have specific services that are very critical, or if you see that specific internet addresses or specific users for some reason are becoming special because they are creating problems to the network. In this case, you want to capture raw packets because they can be used to first investigate the problem and to understand the origin of the problem, more in detail than what you can do with a flow, because in case of security violation, you also want to go deep into the packet. And this is why you need packet-to-disk solutions.
And so, once again, for a question for both of you, I mean, isn't network traffic analysis merely another layer of complexity? I mean, shouldn't we really be thinking about stopping attacks at the perimeter?
Yeah, I'd just like to take that one. I think that, we've relied for a long time on perimeter defenses to try and stop attacks coming in to the network. I think that the hard truth of it is, from the breaches that we've seen over the past while, is that these defenses are just no longer sufficient to ensure that you're going to be safe. There are far too many breaches that are actually being introduced into the network or penetrating these defenses for us to ignore it. And that's why Gartner and others are talking about these as active security frameworks, where you combine detection and prevention capabilities. Detection here, to be quite clear, is looking at your network and monitoring it continuously to see what's going on, because that's the only way you'll see something you haven't seen before. You have to remember that perimeter defenses can only stop what they know. So they'll have databases of patterns and other information about known malware variants. If something that comes in doesn't match that, it's going to be put through, right? So there's certainly, and when we see so many new malware variants, almost one per week, the chances of that happening is quite large. But you also have to think about the fact that we have bring your own devices and cloud services and other things that we're doing in the workplace, which are introducing vulnerabilities from the inside out, right? So we can no longer rely on the perimeter to actually catch anything, because some of the threats are coming in other ways. So perhaps there is another layer of complexity being added to this, but it's very difficult to see how you can avoid that. And perhaps what we need to find in the future is the best balance between how much we invest in the perimeter and how much we invest in the detection capabilities in the network itself. I think it's unavoidable.
I think that's a very interesting point about BYOD, especially, where you essentially the perimeter is actually not a perimeter anymore. It's a constantly shifting kind of line. So I wanted to know what hardware configuration is recommended for Cento.
For 100 gigabit, we recommend an E5 server with 10 or 12 physical CPU cores. These are pretty common these days. And of course, we need the Napatech 100 gigabit Ethernet adapter and a little bit of memory. Usually, we suggest to load the server with 64 gigabytes of RAM, because we want to make sure that we have enough memory for handling traffic peaks. In case you want to also deploy security application onto the box, you should probably double the RAM, because those applications are memory hungry. And if you want to do packet to disk, you should also consider installing a RAID subsystem, but it is fast enough to write the packet to disk without any drop. Usually this is not a problem today, because like I explained before, we don't want to save everything to disk, but we want to save a portion of the traffic, the special packets. So therefore, a RAID subsystem is good enough for doing that. We don't have to go at 100 gigabit, but we have to write at least 10 gigabit to disk. So this is pretty standard in terms of hardware capabilities.
And finally, I want to know for what platforms can Cento be available?
Cento is available for Unix, and in particular, we packaged it for Linux, CentOS, and Linux Ubuntu server distributions. So it's a Linux technology, even though it's portable also to different operating systems. We are focused on those two platforms.
That's unfortunately all we have time for. I'd like to thank our two speakers, Dan, Joe, and Luca, and Napatech as well for sponsoring this webcast, and for giving that riveting presentation. And I'd like to thank you all for joining us.